Lesson 4-6, Solving Systems of Equations with Substitution. We've talked about what a system of equations is in previous lessons. A system of equations is a set of two equations that share a common point, known as the solution. A system of equations can be used to solve for real-world situations, break-even point for business production, number of items that are bought or sold, and there are other applications. And the solution to a system of equations looks like this, the point where the lines intersect. The solution for the system is an ordered pair xy that represents the intersection of the two lines. There are three methods for solving systems of equations. Graphing, which works when you don't absolutely need an exact answer because you don't always get one. It works when the numbers involved are relatively small, so you don't need a large graphing area. We have something called the addition method, which works with any set of equations and is especially useful when the equations have non-integer coefficients. And we have substitution, which works well when one variable has no coefficient and when one line is horizontal or vertical. In the last lesson, we were solving systems using the graphing method, and in this lesson, we're going to use the substitution method. But first, we need to understand what is meant by substitution. Substitution is a property of numbers. It's very similar to substitution in the real world. So if you ask somebody for change for $1, they take your $1 and they give you 4 quarters. You're substituting 4 quarters for $1, but they have the same value. Math is the same way. We can use substitution to solve a system of equations when we remove one expression and replace it with another expression that has the same value. And this allows us to eliminate one of the variables and solve the equation. So using substitution to solve a system of equations when you already have a single variable equal to an expression. We have two examples. And what we do is the first thing you want to look for is a variable with no coefficient. This is the first sign that the system would be easily solved or good to solve with substitution. Okay, looking at our first example, at this equation we have y is equal to 5x minus 11. This tells me that the value of y is the same as the value of 5x minus 11. These are like my $1 and my 4 quarters. In my other equation, I have 2x plus 2y equals 14. What I can do is I can take this y out and replace it with 5x minus 11. So when I do that, I have my 2x plus 2y is equal to 14. Again, I'm taking this y out and putting in 5x minus 11. I can do that because y and 5x minus 11 are the same thing. The 2 doesn't go away, and I replace the y with 5x minus 11. I now have an equation with only one variable, which makes it solvable. I'm going to distribute this 2, and I get 2x plus 10x minus 22 is equal to 14. 2x plus 10x is 12x. Add 22 to both sides, and I get that 12x is equal to 36. I divide by 12, and I get that x is equal to 3. But my solution is an ordered pair, x, y. I know x now, I need to find y. Well, knowing what x is allows me to bring that back up here and plug it in, and that will tell me y is equal to 5x's minus 11. So I take this solution and I plug it into that. So y is equal to 5x minus 11. X is 3, so that's 5 times 3 minus 11. gives me 15 minus 11, which equals 4. So y is equal to 4. So I have x equal to 3, y equal to 4, and that gives me my solution is the ordered pair 3, 4. Okay, in my next equation, I have x equal to something, but I do have the variable with no coefficient x, and x is the same thing as 2y minus 21. This x is also the same thing as 2y minus 21, so I can plug that in. So I have 7x plus 2y is equal to negative 19. Again, I'm going to remove this x and replace it with 2y minus 21. That's a dollar. That's 4 quarters. I distribute the 7, and I get 14y minus 147 plus 2y is equal to negative 19. 14y and 2y is 16y minus 147 is equal to negative 19. I'm going to add 147 to both sides. And I'm going to get 16y is equal to 128. I divide both sides by 16, and that gives me y is equal to 8. So I have one solution, or one part of the solution. I need to find the other. So again, I'm going to plug this into my other equation, x equals 2y minus 21, in order to find out what x actually is. When I do this, I'm going to get that x is equal to 2y minus 21. That's 2 times 8 minus 21. 16 minus 21, so negative 5. X is equal to negative 5. And that makes my solution, the ordered pair, negative 5, 8. Now these worked out really well because I had a variable equal to an expression, so it made it very easy to plug in. Sometimes that doesn't work out. You'll have a variable with no coefficient, but it's not the variable equal to something else. Like in this example, we have this x, or in this example, we have that y. So what we want to do is we want to find the variable with no coefficient. And then the second thing we want to do is we want to rearrange so that it's variable equals expression like we had in the last examples. So I have x plus 7y equals 0. I'm going to subtract 7y from both sides, and that gives me x is equal to negative 7y. Not 74, 7y. Now, in my other equation, which is 2x minus 8y is equal to 22, I'm going to take this thing that x equals negative 7y, and I'm going to replace my x in the other equation with negative 7y. So I'll have 2 times negative 7y minus 8y is equal to 22. That's negative 14y minus 8y is equal to 22. Negative 14 and negative 8 give me a negative 22. Divide both sides by negative 22, and I get that y is equal to negative 1. I'm going to take this negative 1 and I'm going to plug it into what x was equal to in order to solve for x. X equals negative 7y, so that's negative 7 times negative 1, so that's positive 7, so x equals 7, and my solution is the point 7, negative 1. Okay. In my next equation, I have a y without a variable, so I want to solve for that. Or sorry, a y without a coefficient. So I'm going to move the 4x over, And I'm going to have negative y is equal to negative 4x plus 20. But I need to get rid of this negative, so I change all of the signs. It's equivalent to dividing by negative 1. Then I look at my other equation. Y is equal to 4x minus 20, so I'll take this y out and replace it with 4x minus 20. So I'm going to have negative 2x minus 2 times 4x minus 20 is equal to 10. Distribute the whole thing, so negative 2. I get negative 2x minus 8x plus 40 is equal to 10. So I get negative 10x plus 40 is equal to 10. Subtract 40 from both sides, and you get negative 10x is equal to negative 30. Divide both sides by negative 10, and you get x is equal to 3. Now I need to know what y equals. So again, I'm going to take this x and I'm going to plug it in here so I can solve for y. So y is equal to 4x minus 20. So 4 times 3 minus 20. 12 minus 20 is negative 8. So y is equal to negative 8. So my solution is the ordered pair 3, negative 8.